Hi there, folks. Welcome back to the organic molecule naming series. We're going to cover a couple of odds and ends in this one. We're going to briefly talk about benzene and aromatics, and then we're going to talk about halogenoalkanes. We're also going to discuss cyclic alkanes. So first, benzene. Now, there's actually a whole little section of the IB syllabus that we're going to talk about in regards to benzene, but just for now, what you got with benzene is you got a six carbon ring, I guess, and then we have these double bonds, these alternating double bonds. But as it turns out, if you remember what we talked about in bonding last year, these are actually what we call the localized pi bonds, and all these bonds are actually identical. And so you see benzene represented in a couple different ways. You could see it drawn like this, you could see it drawn like this, or you could see it drawn like this with this circle, which is a way to represent the localized nature of those bonds. And the circle is a little more of an accurate way of representing it, and basically what it means is it's just a reminder to you that all these bonds are the same. It's not like there's a strong double bond and then a single bond and a strong double bond. They're all equivalent. As a class, they're called arenes. Phenol as a functional group. You can have just benzene itself, and I'll show you some examples in just a second. We don't really have to do a ton of naming with it, but we definitely have to recognize it, and then we're going to delve into some things about benzene in detail. So that's one thing that we want to look at today, and then the other thing, like I said, is the halogenoalkanes. So with those, these are named as side chains, and they get prefix naming, and based upon the halogen you're talking about, it's fairly straightforward. You change it to fluoro, chloro, bromo, or iodo if it's iodine. And same as always, if there's more than one of them, we're going to use di. We're going to say where both of them are located. So here, for example, we have 3 carbons. We have a propane. There are 2 fluorides attached, so that's 2,2-difluoropropane. Here we have a butane with 4 carbons in a row, and there's 1 bromine attached, so that's 1-bromobutane. So let's look at a couple more examples. So check this one out. We notice the most number of carbons we can count. It's 4. 1, 2, 3, 4. 1, 2, 3, 4. It's always 4. So we have actually 2 side chains here. We have a methyl group and we have a fluorine. The fluorine is going to get numbering priority over the methyl group. As far as when you say them in the name, you say them in alphabetical order. Whoops. So if we do our little naming generator here, we're going to get 2-fluoro-3-methylbutane. 2-fluoro-3-methylbutane. Another example. So again, let's find the longest carbon chain that we can. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it's going to be some kind of hexane. We got these 2 bromines, and we got this ethyl group right here. So again, the 2 bromines are going to get numbering priority. We're going to call that carbon 1. There's 2 bromines, so it's dibromo, and we say where they both are, and then we say where the ethyl group is. So 2,2-dibromo, 4-ethylhexane. Sorry, 1,1. It's on the first carbon. 1,1-dibromo, 4-ethylhexane. Okay, this one. No, notice we have a double bond and we have the chlorine. So we're going to give it that ene ending because it's got the double bond and then it's got the chlorine. This is one of these technicalities. It's not, the double bond is going to get numbering priority over the halogen, and so we're going to call it 3-chlorobut1. That's carbon 1. So just like when we were focusing on naming hydrocarbons, we say where the double bond is, we say where the chloro is. So this, I just popped back on here. That's a representation of benzene. Benzene is a pretty common substance, and then molecules that contain a benzene ring are pretty common as well. I think I mentioned maybe, but they're called aromatics. I have this one on here. It's something you might run into. Notice it's a benzene with an OH attached. That's kind of a special thing. It's called phenol. So just in case that pops up. Okay, so I want to talk about what we call cyclic alkanes, where the carbons have formed themselves into ring-like structures. I don't have a separate card for this one. It's pretty straightforward. The naming mainly works the same, except you add cyclo before it. So, for example, this 3-carbon little triangle here we call cyclopropane. A 4-carbon square we call cyclobutane. Now, both of these things are very unstable because if you think about the bond angles, it'd be 60 degrees here, and here they'd be 90 degrees. Both of those are smaller bond angles than what carbon normally has when it's sp3 hybridized, which they are here, which is 109.5. That causes something we call ring strain. So you would be getting greater and greater stability as you kind of get a larger ring here. But cyclopropane, cyclobutane, cyclopentane, cyclohexane for 6 carbons. So as we add stuff to the ring attachments, or the naming mainly works the same. So like this one, we got a methyl attached to the hexane ring, so we just call it methyl cyclohexane. Now a number is not needed because you can think of this thing like a circle. All these carbons are equivalent, so it doesn't matter. A number would be redundant. It doesn't make any difference. Now if there were 2 methyl groups, same thing. It's similar to when it's a straight chain. We use the die thing. Now here we do need numbers because what that can do, even though it's a circle, it can basically describe where are the methyl groups. Are they on consecutive carbons, or are they like 1 carbon apart like these? So again, give them the lowest possible numbers, so 1,2-dimethyl cyclohexane as opposed to 1,3-dimethyl cyclohexane. So again, same numbering system, just kind of throw the cycle in front of it, but more or less the same. This is not benzene. The difference between this and benzene is this only has 1 double bond, so it's going to be called hexene, and again, a number for that E and E is not necessary since it's like a circle, so the carbons are all equivalent. And just one more example, just to show you the functional group naming is very similar. This is cyclohexanol. Again, no number needed because it's like a circle, it doesn't matter where it is. All right, I think that's about it for this one. Thanks for watching, and we will catch you in the next one. Bye-bye.